Hey guys, we're doing powers of complex numbers. And so I'm going to be using Kahn Academy and 3blue1brown to help you visualize this. Now, if you're doing powers and exponents, you're doing repeated multiplication. Notice over there, I've got a radius times itself, right? Because you're going to multiply two polar complex numbers first by taking their radii and multiplying. So r times r is r squared. And then you take the angles and you add them. Well, if you're multiplying by yourself, you get the same angle, so you end up with 2 theta if you add them. Similarly, if you do cubed, then you have r cubed, and you do theta, then you get 3 theta, and z to the 4th, z to the 5th, 4 theta, 5 theta. And so this is really helpful for that repeated multiplication of either different complex numbers or, in this case, the same complex number. So your rule is right over here. Very easy to do, all right? Let's go to Kahn Academy. Where is that? Oh, there it is. All right. Kahn Academy is using 3blue1brown. This is the YouTube channel that did that COVID-19 logistic curve that we looked at. Really awesome channel. If you have a chance, subscribe to them. But this is me stealing someone else stealing someone else's work. No, I'm just kidding. They're borrowing it. So I'm borrowing Kahn Academy's borrowing of a 3blue1brown clip. Now, Kahn Academy does a nice job of putting the context to the video, so I appreciate that. And what you have to understand is if I have 1 plus I root 3, that complex number is the same thing as 2 cosine 60 I sine 60, because basically if you do 1 over and root 3 up, the distance from the pole would be 2, right? So you can say it's the radii, it's the modulus of the complex number, it's the hypotenuse of the reference triangle, right? So let's take a look at this video starting from the beginning. Now, the first thing you want to notice is that they start with 1. And the idea is that you have to think that 1 is actually 1 plus 0i. And that's in the 0 degree or 0 radian direction, right? So you can actually write that as cosine of 0 plus I sine of 0, right? Because sine of 0 is 0. So the imaginary part isn't part of this. It's just 1, right? Cosine of 0 is 1. I sine 0 is 0. So you only have the you only have the real component in this case if you start at 1. Now, what happens if you multiply by 1 plus I root 3? Notice that if you do 1 times 1 plus I root 3, it was a rotation of 60, right? From 0 degrees to 60 degrees, you add 0 and 60, so that's 60 degrees. And you multiply your radius of 1 by 2. So now you have 2 cosine 60 I sine 60, right? So that would be 1 plus I squared of 3 to the first power, right? What happens if you do 1 plus I squared of 3 to the second power? Well, remember, you'd add the angle, so you'd add another 60 degrees, so 60 plus 60 is 120, and you'd multiply again the radii by 2, so instead of having a distance from the pole of 2, you would then have it at 4. Right? As you can see, if I do to the third power, well, just think about it. I've done 60 and 60. That's 120. Where am I at if I add another 60 degrees? Think about it. 180. Hopefully that's what you got, because 60 plus 60 plus 60 is 180. And what do you think the radii will be? Again, it's actually right over here. It's 8. And because it's in the direction of 180 degrees, it'd be negative 8. And that's so intuitive. But if you did the math out, if you did 1 plus I root 3 times 1 plus I root 3 times 1 plus I root 3, and you simplified it, you just get a negative 8. But instead of looking at it from the complex form, the standard form, you could just look at it from the polar form and just know that, oh, cosine of 180 is 1 and sine of 180 is 0. And so you're back to having a 0 for your imaginary component and a 1 for your real times 8. So that's your negative 8, right? Sorry, cosine of 180 is negative 1. So negative 8 would be your real component.